Question 7, the coordinates of 2 points A and B are 1, 3 and 9, -1, and D is the midpoint of AB. A point C has coordinates x, y, where x and y are variables. In part 1, we have to state the coordinates of B. So in the first step, as it is the midpoint of AB, so we'll use the formula x1 plus x2 upon 2. So that will become 1 plus 9 upon 2, comma, and y1 plus y2 upon 2. So that will become 3 plus -1 upon 2 for the midpoint of AB. Simplifying this, we'll get 1 plus 9, 10 upon 2, which is 5, and 3 minus 1, 2 upon 2, 5 and 1. So these are the coordinates of D. In part 2, it is given that CD squared is equals to 20. We have to write an equation relating x and y. Now we already have the coordinates of D, which are 5, 1. We can assume that the coordinates of, well, it is given in the question that the coordinates of C are x, y. So the distance formula is, so if you're finding the distance of CD, that will be x2 minus x1 whole squared plus y2 minus y1 whole squared. So we can take this as x1, y1, and this as x2 and y2. So CD will be is equals to square root of, so that will become x minus 5 whole squared plus y2, so that will become y minus 1 whole squared. And as CD squared is equals to 20, and we'll whole square both the sides to get rid of the square root sign. So we'll get CD squared is equals to x minus 5 whole squared plus y minus 1 whole squared. And as CD squared is already given as 20, so we can write the final equation as x minus 5 whole squared plus y minus 1 whole squared, and that will be equals to 20. In part 3, it says it is given that AC and BC are equal in length. Find an equation relating x and y and show that it can be simplified to y equals to 2x minus 9. Now we have the coordinates of A, which are 1, 3. We have the coordinates of B as 9, -1, and the coordinates of C are x and y. So as the lengths are equal, so we can apply the distance formula to AC and BC and equate the two equations. So first finding the distance of AC, so that will become square root of x2 minus x1, so that will become x minus 1 whole squared plus y2 minus y1 will become y minus 3 whole squared, and that will be equals to the square root of the distance. So the distance of BC will become x minus 9 whole squared, and this will become y minus 1 whole squared, so that will become a y plus 1 whole squared. Now we'll whole square both the sides, and the square roots will cancel out with the whole square, so we'll get x minus 1 whole squared plus y minus 3 whole squared. And expanding this, we'll get x squared minus 2x plus 1. Expanding y minus 3, that will become y squared minus, so that will become 6y plus 9. Expanding this will become x squared minus 18x plus 81. And this will become y squared plus 2y plus 1. Now, on both the sides, we have x squared and x squared, so they will cancel out, as if we take the x squared on the right-hand side or the left-hand side, it will cancel out. The y square will cancel with y squared. Now we can bring this 18x and the 2y on the left-hand side, so can be written as, so this will become minus 2x plus 18x. This is a minus 6y, and that was a plus 2y, so this will become a minus 2y is equals to, this is 81 plus 1, and this is a 9 plus 1, 10, so this will become a minus 10. Simplifying this, we'll get 16x minus 8y is equals to 81 plus 1 is 82 minus 10, that will become 72. And as we have to give it in the form y equals to 2x minus 9, first we can divide the whole equation by 8. So this will become 16x upon 8 will become 2x minus y is equals to 72 divided by 8 is 9. Taking y on the right hand side, we can write the final equation as y equals to 2x minus 9, as we had to prove in the question. In part 4, it says using the results from part 2 and 3, we have to find the possible coordinates of C. Now, one of the equations we got was x minus 5 whole squared plus y minus 1 whole squared, and that was equals to 20. And the second equation we got from the third part was y equals to 2x minus 9. Now, as x and y are the coordinates of C, we can solve these equations simultaneously to find the value of x or y. So using the substitution y equals to 2x minus 9, we can first write this equation as x minus 5 whole squared, and in place of y, we'll get 2x minus 9 is equals to 20. Simplifying this, we can write it as x minus 5 whole squared plus 2x minus 10 whole squared equals to 20. And now expanding the expression, we'll get x squared minus 10x plus 25. This will become 4x squared minus, so this will become 10 times 2, and multiplying by 2, that will become a minus 40x plus 100 is equals to 20. So x squared plus x squared, that will become 5x squared minus 10x minus 40x will become minus 50x. 100 plus 25 is 125, and when we can bring the 20 on this side, so we can now write this equation as 5x squared minus 50x, and this will become 125 minus 20, which is plus 105 equals to 0. To simplify this equation, we can divide the whole equation by 5 and write it as x squared minus 10x plus 21 equals to 0. We can use our calculators now to solve this quadratic equation, or we can just factorize it by using the factors 7 and 3. So this will become minus 7 and minus 3 equals to 0. So the two values of x will be equals to 3 and x will be equals to 7. Once we have the x values, now we can find the y values by substituting this x value in either of the two equations. So using the simpler equation, which is y equals to 2x minus 9, so this will become 2 into 3 minus 9, and this will become y is equals to 2 into 7 minus 9. So it's 6 minus 9, the y coordinate will become minus 3, and over here the y coordinate will become 14 minus 9, that is 5. So we can write that the possible coordinates of C can be 3 comma minus 3 and 7 comma 14. So this will become, okay, so that is 14 minus 9, that is equals to 5. So this will become 14 minus 9, which is equals to 5. So this will be 7 comma 5.